This video is about the characteristics of an effective experiment and how to design a good experiment. As we go, we will continue to look at the vocabulary of experiments, talking about subjects, treatments, explanatory variable versus response variable, lurking variables, control group, placebo effect, etc. Problem number 1. A study of the effect of living in public housing on family stability in low-income households was carried out as follows. A list of applicants accepted for public housing was obtained, together with a list of families who applied but were rejected by the housing authorities. A random sample was drawn from each list, and the two groups were observed for several years. Is this an observational study or an experiment? Explain. When you're asking the question whether or not it's an experiment or an observational study, you should be asking yourself, did the researcher control who went into what group, or was that set by other factors? So in this case, the researcher only compiled these lists. The researcher did not decide, okay, these people are going to get housing and these people won't. All right, that was carried out by the housing authorities. So since the researcher did not control who went into what group, this is an observational study. All right, just for comparison, let me explain what an experiment would have looked like in this particular context. Imagine that the researcher got permission from the housing authority to be the one who decides who gets public housing and who doesn't. So imagine that the population was everyone who had applied for public housing. But instead of whatever criteria the housing authorities used, imagine that the researcher used a random number generator to randomly assign, let's say 100 people to get public housing and 100 people to not get public housing. So then if you compared what happened to those two groups, that would be an experiment, because now the researcher, using his random number generator, is deciding who goes into what group. Alright, now going on to talk about part B here, what are the explanatory and response variables? When you think about explanatory variables, you should be thinking these are the potential causes, and the response variables are the potential results, sort of like cause and effect. It's not a fact, but these are that's a good way to think about it. Potential causes and possible results. So in this case, of course, the explanatory variable is the thing that we are studying, the thing that we're thinking about controlling and seeing what difference it causes, and that's whether or not a family gets public housing. So the explanatory variable is getting public housing or not. On the other hand, the response variable is the potential results of getting public housing or not. And as far as the way that the study was set up, it says that they were trying to study the effect of public housing on family stability. So they're specifically studying what happens to the family stability. So family stability is going to be the response variable. Now, family stability means, did the family stay together, and a family could split up in different ways for a variety of reasons. If one of the family members goes to prison, that's a it goes against family stability. If somebody dies, there's no family stability. If a child runs away from home, no family stability. Things like that are what they're talking about when they talk about family stability. All right, moving on to part C. Does this study contain lurking variables that may prevent valid conclusions on the effects of living in public housing? Well, yes, and it goes back to the fact that this was not set up as an experiment in the first place. It's an observational study, and so because the two groups, the public housing group and the non-public housing group, those two groups are not the same in the first place. The way those two groups were decided is one group was accepted by the housing authorities, and the other group was rejected by housing authorities. So I don't know what the standards are that the housing authorities use to decide who gets public housing, who doesn't. But whatever their standards are for rejecting some people and accepting others, that's the housing authorities see a clear difference between these two groups of people. So whatever that difference is, that's going to cause lurking variables. So maybe they're rejecting people, just for example, because they see that the family is too unstable to benefit from public housing. If they see that there's been a history of crime, a history of violence, a history of drug abuse, that might be one of the things that eliminates a family from qualifying for public housing. And so by putting all those rejected people in one group, then that group of people that were rejected for public housing, they will automatically be a lot more likely to be unstable, have an unstable family. And that would have nothing to do with getting public housing or not, would not be the cause of the instability. It was already there because of the way they made the group. So again, to eliminate those lurking variables, what they would need to do is, if they just got one big group of people, like for example everybody that applied for public housing in one big group, and instead of using some sort of criteria to separate them, just using random chance to separate them into groups, then if you give one group housing and deny the other group housing, then you can compare and see, well, okay, the only thing different about these two groups is now that one group got housing and the other group didn't. So then if you see, okay, the group that got the public housing, 3 years later, all the variables show that they're much more stable, then you can conclude that it's the housing. It would be a valid conclusion that it must be the housing that's the difference. But if you use these criteria to make the two groups, then you really can't draw any valid conclusions. Now, the reason why they don't do it that way is it's seen as unethical to just randomly to say, okay, you guys get public housing and you guys don't. So these are human beings and they have lives. So just to deny people public housing just for the benefit of a study, it's not seen as ethical. So that's why they don't actually do it that way. Okay, let's move on to number 2. Researchers in Japan conducted an experiment on 13 individuals who were extremely allergic to poison ivy. On one arm, each subject was rubbed with a poison ivy leaf and told the leaf was harmless. On the other arm, each subject was rubbed with a harmless leaf and told it was poison ivy. All of the subjects developed a rash on the arm where the harmless leaf was rubbed. Of the 13 subjects, 11 did not have any reaction to the real poison ivy leaf. What was the placebo in this experiment? The placebo in this experiment was the harmless leaf. To explain how the results of this study support the idea of a placebo effect, Well, the placebo effect is when the subject has a reaction to a treatment that is known to have no effect. And in this case, all the subjects developed a rash from a harmless leaf because they believed that it was poison ivy. So that's a clear evidence for the placebo effect. And plus, these individuals were all extremely allergic to poison ivy. So the fact that that most of them did not have any reaction to the real poison ivy, simply because they were told that it wasn't poison ivy, that also is evidence of the placebo effect. Alright, moving on to number 3. A researcher conducts an experiment to see if a new vitamin increases a person's energy level. The experimental group consists of college students who are given the vitamin daily. The control group consists of college professors who are not given the vitamin. The researcher finds that the energy level of the people in the experimental group is greater than those in the control group. As a result, the researcher concludes that the vitamin is effective. Identify any flaws in this experiment and describe how they can be corrected. The obvious problem here is that the experimental group and the control group are not similar at all. The experimental group consists of college students who are obviously much younger than the control group, which is all college professors who are going to be older. So you would expect the younger group to have a higher energy level. So the fact that those groups are not the same makes it impossible to compare them and know what the actual benefit of the vitamin is, if any. So obviously the way that you would fix this is put everybody who's going to participate in the experiment into one big group, say a mixture of a mixture of the professors and the students, and then choose who's going to be in which group, who's going to get the vitamin and who's going to get, say, a placebo would be actually another thing to introduce here. So everybody gets a pill. So you could decide who's going to get which treatment by chance. Now, if you wanted to do a stratified sample and, for example, randomly pick, let's say if we were going to do 50 people getting each treatment, then I'd say randomly pick 25 students to get the vitamin, and randomly pick 25 professors to get the vitamin, and then randomly pick 25 students to get the placebo, and pick 25 professors to get the placebo. So that way you have an equal number of younger and older subjects, and so you could eliminate the bias created by having a younger group compared with an older group. Alright, so here I've basically written up what I just got through saying. Okay, by the way, speaking of, oh look, I've just written this up. There's been an epidemic of students just straight copying my work, and it's really obvious, you guys, when I see your homework paper and I see my exact words or the exact calculations that I did in the exact places, and especially if I make a mistake or a typographical error, it makes it really obvious when I see 10 students that copy down faithfully my typos. Then I know you're just mindlessly copying what I do. So please understand that A, obviously you're not learning anything that way, but B, if I catch it and it becomes obvious like that, I'm not giving you credit for the assignment. So, there's that. Alright, let's move on to number 4.
Hello, Daddy, students.
Hi, Maya. Determine which group is, yeah, that's what you guys sound like, by the way. Hi, Maya. Determine which group is the experimental group and which group is the control group in the study. Okay. So let's see. A researcher is conducting a study to determine the effect of the flu vaccine on preventing the flu. The participants in the study are a group of people who received the flu vaccine and a group of people who did not receive the flu vaccine. All right. Yeah, the people who received the flu vaccine, they're the experimental group. The people who did not receive the flu vaccine are the control. If they really wanted to do it right, they'd give the non-flu vaccine people a placebo shot to eliminate the placebo effect. All right, go ahead.
So if you just copy it, then you're not going to get anything from it because you're not actually learning it. You're just doing exactly what you were trying to be taught, but you were hopefully being taught to do, but instead you're just mindlessly copying it without putting any real work into it and trying to learn it.
Yeah, would you do that?
No, but pretty much all the boys in my class always do that, just to go out and like play and stuff.
Do you think that'll help them get ahead in life?
No. And when they try and get a job, they're gonna be like, "What? I never learned this." When they were going to learn, and they're supposed to be learning it in 3rd grade.
All right, part B. A school district is performing a study to determine whether or not an SAT prep course increases a student's SAT score. The participants in the study are a group of students who do not take the prep course and a group of students who do take the prep course. Yes, the experimental group will be the group of students who take the prep course. The control group is the people who do not take the prep course. All right, part C. A researcher is conducting a study to determine the effects of caffeine on a person's heart rate. The participants in the study are a group of people who drink coffee daily and a group of people who drink coffee occasionally. Okay, so if they're trying to determine the effects of caffeine, then the experimental group, if I had to choose, will be the group who drink coffee daily, and because the occasionally coffee drinking people are the closest thing to non-coffee drinkers. It seemed like a pure experiment and control would be coffee drinkers and non-coffee drinkers, but this is as close as we can get. Kabam. All right, let's see. Let's move on over to the back. A couple more questions. So number 5, a researcher is conducting a study to determine the effect of a new sunscreen, has on the prevention of skin cancer. The experimental group consists of lifeguards at an ocean resort. The control group consists of housekeepers at an ocean resort. Identify any flaws in the experiment and describe how they can be corrected. Again, the number one thing here is your experimental group and your control group, except for the treatment that you're giving them, the group should be as similar as possible. So by having your experimental group be lifeguards and your control group be housekeepers, those groups are not similar at all. We're talking about sunscreen, and obviously the lifeguards are out in the sun, and the housekeepers are inside. So if it were to turn out, for example, that the lifeguards are getting more cancer as the years go by, we wouldn't know whether it has anything to do with the sunscreen or whether it's because they are out in the sun. If the housekeepers are getting less cancer, we don't know if it's because of the great sunscreen or because they're indoors most of the day. All right, so the way to correct that would be to have all of the subjects in the experiment put into one big group and just randomly choose who is going to get the sunscreen and who's going to not get the sunscreen, and then measure based on that. All right, that way your experimental group and your control group would be the same, and the only difference would be the treatment. So any differences in outcomes like cancer, it would be more reasonable to conclude that those differences are being caused by the treatment. Alright, and here I've basically written up what I just said. So, number 6. A large study used records from Canada's national healthcare system to compare the effectiveness of two ways to treat prostate disease. The two treatments are traditional surgery and a new method that does not require surgery. The records described many patients whose doctors had chosen each method. The study found that patients treated by the new method were significantly more likely to die within 8 years. Further study of the data showed that this conclusion was wrong. The extra deaths among patients who got the new method could be explained by lurking variables. What lurking variables might have confounded the doctor's choice of surgical or non-surgical treatment? Well, surgeries are very often risky, and if they put you under anesthesia, they always tell you that there's always a risk of complication. Anytime you're going under anesthesia, anytime you're having surgery, there's a risk. So it's very possible that the patients that were recommended for the non-surgical procedure were more vulnerable. Maybe they were older, more fragile. Maybe they had other illnesses that made it more dangerous for them to get the surgical procedure and survive it. So if you were to conclude that, oh, well, look, the new non-surgical method is dangerous because more people are dying from it, then that could easily be a false conclusion, when really it's because the lurking variable that the people who were recommended for the non-surgical treatment were more fragile and vulnerable to begin with. Alright, and here I've written up what I just said. Okay, on the other hand, you have 300 prostate patients who are willing to serve as subjects in an experiment to compare the two methods. Use a diagram to outline the design of a randomized comparative experiment. Well, for starters, you take your 300 subjects and you randomly assign them to two groups. So we have 150 put in group 1, 150 put in group 2, 100% randomly. Alright, and then you assign each group one of the two treatments. So you can say group 1 gets the surgical treatment and group 2 gets the non-surgical treatment. But it could have been the other way around. Maybe group 1 could get the non-surgical treatment and group 2 could get the surgical treatment. And again, you want to assign the treatments to the groups randomly. So, alright, so the subjects were randomly assigned to the groups, and then the treatments were randomly assigned to the groups. Alright, and then we're just going to compare the results. And that's it. That's how that would be a good design for this experiment. Alright, last question. Eye cataracts are responsible for over 40% of blindness around the world. Can regularly drinking tea slow the growth of cataracts? We can't experiment on people, so we use rats as subjects. Researchers injected 18 young rats with a substance that causes cataracts. One group of rats also received black tea extract. A second group received green tea extract, and a third got a placebo, a substance with no effect on the body. The response variable was the growth of cataracts over the next 6 weeks. Outline the design of this experiment. Alright, well, since there are 3 treatments that we want to do, we want to take our 18 rats and randomly assign them to 3 groups. So that's the first part of my diagram. And then each one of these groups are going to be randomly assigned a treatment. Alright, and here's how I would show that. So it could have easily gone a different way, where group 1 got the placebo, group 2 got the black tea, and group 3 got the green tea. So we're going to randomly assign the treatments. And then we're just going to compare the results. And that's how you could do a good experiment design for this particular situation. Alright, that is it for this lesson. I hope it was helpful. I hope you didn't just copy off of me like too many of you do. And I will see you on the next video.